Good morning, everybody. Thank you for taking time out of your day to join me on this wonderful Canadian Thanksgiving. Really means a lot to me. Today we're going to scrape the surface on some of the most contemporary topics and possibly contentious topics in open source AI. With that, let's dive right into our first topic. It's an easy one. Let's define open source AI. So when we talk about open source AI, the complexity runs much deeper than traditional open source software. In classical open source, the code was the product, right? If the source code was licensed under GPL or Apache, the case was clear. But in AI, what is the product? Is it the model architecture and the associated weights? Is it the training data? Is it the other components that are involved in the inference stack? And each of these components really has different meaning and a different relationship towards openness, licensing, and reproducibility. So for instance, some people define open source AI as releasing both the model and the weights under a permissive license. Others argue that without access to training data and the process that went in preparing that data and training the model, that the model truly isn't open. And so that's more akin to open science, and they view that that is, open source AI. And then there's others like myself that believe that open source AI is really the entire ecosystem of open source in AI. So projects like PyTorch and VLM and other AI infra projects, but also like application frameworks, agentic frameworks, and a lot of these agentic protocols that are emerging. And regardless of the definition, I think we can all recognize what open washing is. We know it from open source software, and we see it again with open AI. And really, that's when models are released, and they're released under a restrictive license, or there's trigger clauses that cause you to negotiate a new license. So when someone says, what is open source AI? The real question is, open in what sense? And to whom? That's the heart of the controversy, and why defining open source AI remains one of the most contested topics in the industry at the moment. These are not lined up. All right. So even with the debate about what open means in AI, openness is still thriving. We saw a dip in open research and the release of open models between 2023 and 2024, but 2025 has kind of come back with a resurgence, especially from Chinese labs. DeepSeek, Alibaba's Qwen, Moonshot AI, Z.AI have all released a lot of innovative new techniques in open science and released models under permissive licensing or under community licenses. And it's not just them. Nearly all labs now have open models or open weight models. Actually, all of them do now with XAI release of Grok 2 and OpenAI's GPT-OSS, save one, and I will not mention their name. Open research is also alive and well. Independent labs continue to publish innovative papers on model efficiency, safety, and interpretability, keeping scientific progress open, and even though some commercial labs are still growing to be more secretive. Those commercial labs that are choosing opacity are offering technical reports instead of reproducible results, and this is really a short-sighted path. History shows that transparency and collaboration drive breakthroughs that sustain the AI ecosystem. So while the definition of openness may be evolving, its spirit of shared progress and collective innovation remains one of the most powerful forces in open source AI today. When we talk about open models, licensing quickly becomes one of the murkiest areas. So traditional licenses like MIT and Apache 2.0 were always designed for software code, not for AI models, not for architectures, not for weights, not for data sets. And they simply don't account for how AI systems generate, transform, and learn from data. This leads to real legal ambiguity. For example, if GPT-OSS is released under Apache 2.0, and I use it to generate code, is all of that output code now licensed under Apache 2.0? Has OpenAI effectively licensed out copyright over every piece of generated text, audio, and video? And what about users fine-tuning models? Do they own their outputs, or are they bound by their upstream license? What happens when a company fine-tunes a base model and commercializes it? Is that considered derivative works, or is that also independent IP? And these are gray areas, right? The traditional software licenses simply don't hold up. And that's why we're seeing emerging model licenses being developed now, including OpenMDW from the Linux Foundation, designed to cover the entire AI model stack, including data, weights, and outputs across copyright, patent, trademark, and database rights. But adoption remains slow. Most developers are still default to traditional open source software licenses because they're comfortable, but they're not really built for the realities of AI. So we're entering what some may call the vibe coding era, where developers use natural language prompts to tell AI copilots or agents what they want, and then the AI writes the code. It's intuitive, fast, and democratizing access to software development in ways we've never seen before. But this is part of a larger shift towards intent-based or intent-driven programming, moving from writing syntax to expressing intent. And tools like Windsurf, Cursor, and GitHub Copilot make it possible for people to build working prototypes or even production-grade systems with very little traditional expertise in programming. But there's a trade-off. With accessibility comes risk, hallucinated code, hidden vulnerabilities, and long-term maintainability problems. The more layers of automation we introduce, the more fragile our systems may become. So one of my biggest gripes right now in the AI space is around benchmarks and leaderboards. So labs often cherry-pick benchmarks, publishing the ones that their models perform best at, and quietly eschewing any of the ones where their performance lags. And this results in a distorted view of capability. So a model might look like state-of-the-art on paper, but actually doesn't generalize well across real-world problems. Even more problematic, most leaderboards aren't comparing apples to apples. So we're seeing raw, open models being compared against published API products that include prompt routers, post-processing, and guardrails. And that's not really a level playing field, to be honest with you. It's kind of marketing disguised as measurement. So there's also the issues of training data pollution. Many models are being directly or indirectly trained on benchmark data. And this really means that they're optimized for the test itself, not for generalization. And benchmarks can be useful, certainly, but they're not synonymous with intelligence. So what we need are evaluations that measure real generalization, not just leaderboards. Because at the end of the day, performance on a benchmark isn't the same as performance in the real world. And as you may know, everything is now AI. Everything is now an AI agent. So we're watching AI rapidly move from being assistive tools to being autonomous actors. And that changes pretty much everything. Today's AI copilots, whether coding, office productivity, or creative tools, operate within defined boundaries. They help humans make decisions, generate content, or automate repetitive workflows. But they still rely on guidance and oversight. They're co-pilots, they're not captains. The next evolution is autonomous AI agents, systems that can reason, plan, and take action independently. These agents may maintain memory, reason over time horizons, and invoke tools or APIs on their own without human intervention. And that's powerful, but it's also very risky. As we increase autonomy, we increase risk, and the performance, safety, and governance challenges will mount up. And we need to ensure that these systems are capable, but also need to be very reliable, auditable, reproducible, and aligned. When we talk about the future of AI, the conversation often focuses on model architecture or compute. But the real crisis lies in the data. We're seeing a shrinking supply of authentic human data. And the web is producing less and less original human-created content as AI-generated material floods online spaces. That means future data sets are losing diversity, creativity, and nuance that once fueled model innovation. At the same time, we're facing data contamination issues. Models will increasingly be trained on synthetic outputs created by other models. This leads to a kind of data inbreeding, where biases and errors are amplified, through feedback loops and producing flatter, less reliable results. And the consequences is what researchers call model collapse. A gradual degradation of factual accuracy, reasoning, and the originality as models feed on their own synthetic outputs. We also risk the erosion of ground truth. As AI content and human-generated content become indistinguishable, our ability to filter and ground and verify AI systems and real-world knowledge becomes increasingly difficult. In 2023, AI-generated media was amusing. Will Smith eating spaghetti looked like a fever dream. 2 years later, only 2 years later, really, it's nearly photorealistic. That's the story of synthetic media. It's rapid evolution and has enormous implications. We're witnessing a blurring of truth and fiction. AI-generated text, audio, and video make it harder than ever to tell the real world from what is fake. And this really undermines trust in news, identity, and even our sense of shared reality. At the same time, these tools democratize creativity. Anyone can produce Hollywood-quality visuals and professional-grade content, unlocking new voices and accelerating innovation. However, we cannot forget about copyrights, identity, and privacy, and let's just say that is a legal minefield that I am not going to touch. And if you listen to the AI doomsayers, the story goes within a decade, robots will have taken every job, developers will all be out of work, and humanity will be paying for all those times that we kicked robotic dogs during these demo videos. But the reality is far more nuanced. Many jobs are exposed to AI, but are not at risk of being replaced by AI. What we're seeing is a transformation and not extinction. So yes, AI is reshaping work, but it's happening gradually, not apocalyptically. And the future of jobs isn't about replacement, it's about reinvention and augmentation. And there are undoubtedly many challenges in open source AI. I only scraped a few of them here, but if we work together and we collaborate on open solutions, we can collectively benefit from the rewards of AI and developing it responsibly and developing it in the open. And thank you very much, and please keep the future open.